Good afternoon, everybody. Welcome to our presentation where we'll be talking NHRA top fuel motorcycles with Vantine Nitro-Sports and PennGrade1. My name is Greg Jones. I'm the content director for the Power and Performance Group here at Babcock's Media, and I'll be the moderator for today's webinar, which is sponsored by PennGrade1. And in case you guys didn't know, top fuel motorcycles are becoming a full race class in the NHRA this year. These 1,000+ horsepower machines feature nitro flames and carry the front tire in the air past half track, reaching 100 miles per hour in 1.25 seconds and exceeding 200 miles per hour in under 4 seconds. Today, we'll be talking about the crazy pressures and forces that these top fuel motorcycle engines are under and why Dave Vantine has trusted PennGrade1 to protect his team's engines when it matters the most. Now, before we get into that discussion, there are a few housekeeping items that I have to discuss. As part of this webinar, we will have a live Q&A session. We will address some of those questions during the last portion of the event. And to improve the chances of your question being answered, please do not wait until the end to submit them. Please ask those questions as you think of them. And to ask a question, simply type your question into the Ask a Question box and click the Submit button. Now, it's something for you guys to consider is that this webinar is being recorded, so it will be available on demand for you to view and to share. Tomorrow, you guys will receive an email with a link to the recording, and it will also get posted on both the Engine Builder and the Motorcycle and Power Sports News websites. Within this webinar software, you have the ability to open, close, and resize different elements on your screen. So to make a window larger or smaller, just grab the corner of the window and drag it. You can also make some windows full screen by clicking the Maximize button in the upper right corner of that window. If you want to receive a certificate of attendance, you can click on the graduation hat icon within the black toolbar that's located on the left side of your computer screen. And in that same toolbar, you'll also find icons to share the webinar through email or social media. If you're viewing on a mobile device today, you may need to click the 4 dots menu in the upper right corner of your screen to view those icons. Now, as always, your feedback helps make our events better. So please click the survey icon to leave your comments about today's topic and presenters. This survey will also appear in the middle of your screen toward the end of today's event. Now, if at any point during our discussion you guys need help, please send a message through the Ask a Question box. And finally, if the slides stop advancing or if you're having problems with audio, try pressing the F5 key at the top of your keyboard or Command R if you're using a Mac. Both of those will refresh the webinar on your screen. Okay, so that's the housekeeping items out of the way. Now I'd like to introduce today's presenters. We are happy to have Nick Dixon joining us today. Nick is a territory business sales manager for DA Lubricant Company and has more than 40 years in the oil industry. We would also like to welcome Team Vantine to today's webinar. We're joined by Dave Vantine, owner and rider for Vantine Nitro-Sports. Dave began motorcycle drag racing in 1987 and continued to climb the racing ranks in the Pro Mod class and made the jump to top fuel around 2011. Dave has become one of the most successful nitro racers ever in a very short period of time. He's also joined by co-crew chiefs Greg Pollard and Joe Taranto joining us today. Greg started racing in 1991 and spent 9 years in the funny bike class before moving to top fuel in 2001. And Joe has been a racer for many years and holds degrees in both mechanical and automotive engineering. Welcome, guys. Thanks for joining us today. How's everybody doing?
Good.
Great to be here.
Yep, happy to be here.
Now, I do want to just let our attendees know, I mentioned Nick's name with DA Lubricant. Fortunately, he was having a couple issues and and I don't know that he's joined us yet. So hopefully he's able to join as we go along. But if not, he will be missed. But we still have a great presentation for you guys here with the Vantine team. So with that, let's get into it. So Dave, I wanted to start, obviously you've been in this motorcycle drag racing game a long time. But I was hoping we could start with a little bit of background about Vantine Nitro-Sports and kind of how the team got together and got to where it is today.
Well, originally I started racing for Greg Pollard, and he was the previous owner of that bike. I had at the time decided that, top fuel racing was probably not going to happen because of the amount of time, tools, and expertise it took. So Greg was nice enough to give me the opportunity to ride the bike for a while. I rode it for a bit and then purchased, the team from Greg. And he, agreed to come with it. And Joe and I have been racing together for a long time, and Joe's a quick study. And so we sort of formed a team, and, it's done quite well. With certainly the tutelage from the McBride brothers, Larry and Steve. I think, in certain areas, there's no doubt that helped accelerate the process.
Yeah, excellent.
Yeah,
no, that was great. Now, obviously, there's three of you at the table today, but I'm sure there's far more people who are part of the team that make that racing happen every weekend.
I think we have about 10.
Okay.
Total.
Very good.
From truck drivers to oil changers to tire people to electricians to the hospitality. When we have folks that cook. It's a hungry bunch come the end of the day.
Yeah, very good.
So it's and it takes everybody. I mean, everybody's important. You certainly notice it if any, and we've as of late, in Maryland testing, we were down 2 of our normal crew, and it showed.
Yeah, I can imagine that everyone's doing quite a bit when it's when the competition is as fierce as it is for what you guys do.
There's that, and like all drag racing, as rounds go by, the better you do, the shorter the turnaround time is. So, when you get between a semifinal and a final, it's time to move.
Very good.
You got to get back and get after it, especially if you've wounded an engine and hurt a tire, both.
Yeah.
All of a sudden, it's pretty quick.
Yeah, and we'll definitely get into more of that here in a second. But I also wanted to know, how long the relationship has been between Vantine and PennGrade1, and specifically what type of weight and viscosity oil do you guys run?
I can answer that, or go ahead.
The relationship with PennGrade goes back to about 2008 or 2009. So we're about 15 years. When we first put the bike together and got it on a track, we looked at the options for oil, and back then I think it was called Kendall, and migrated to the PennGrade name, and we've been with them ever since. And we used a 50 weight, straight 50 weight oil, and it's been dependable. We never really had an oil related failure that we know of, and that's why we've stayed with it through all this time.
I think, Joe will tell you, sometimes when we return our engines for a freshen up, they take them apart and wonder why we even sent them back to get worked on in the first place. I mean, that goes a long way to how they tune the engines, but certainly the PennGrade1 oil had something to do with it.
We typically, like, one of our biggest things is trying to keep track of attrition on parts. So we take them back apart, measure bearing thicknesses, this, that, and like David just said, most of the time they're like, why did you even bother sending it? But just peace of mind more than anything. But no, it's been a very reliable and repeatable product, and happy to be with them. That's for sure.
Yeah, no, that's certainly great to hear. And yeah, 15 years is a long time to be running the same oil. So that certainly speaks to the success that you guys have had and how PennGrade has
Yeah,
helped.
'cause as you well know, and nitro anything destroys oil quickly. We all nitro cars, motorcycles, anything with nitro in it, it's good for one pass, and that's it. And the fact that the PennGrade1 oil stands up to nitromethane is big. Because there's a lot of oils out there that I don't believe do as good a job, even though they're called like nitro, oil. It's because if you've ever been around a top fuel car, rail or funny car, it comes out like foamy milk after 3 seconds.
Yeah. Yeah, and guys, we'll definitely get into more of that oil conversation here, as well as what you guys are doing with the engine between rounds in a second. But I wanted to go back to something I mentioned in the introduction, which is that Top Fuel motorcycle drag racing is now going to be a full class in NHRA, which it hasn't been for a very long time. So, Dave and team, I wanted to ask, what has Top Fuel motorcycle drag racing kind of been like for the past 20 years or so, and what does it mean now that you guys have this full class in NHRA?
Well, and it kind of goes to some of the questions that you had below, like what's next questions. What it's been like is, over the years, varying people, have sort of carried the, nitro motorcycle flag. The class got down to as few as 2 people. And, it's sort of had a resurgence in the last 4 or 5 years. The NHRA, the hope, is as most people is that there's more people, because there are a fair number of bikes that are out there that just need to be updated with some of the newest stuff. You dust off the riders a little bit, and we're the hope is that maybe if NHRA doesn't do it for them, then it can't be done. So our hope is that, this NHRA thing that we, Larry and I spent the last 2 seasons building and, it became a class, is that with any luck, that's going to be a turning point to grow the class. So we're hoping, exposure, people, television, people are like, hey, I want to do that, because I believe the focus of people coming up through the ranks these days have changed.
Yeah.
When I was growing up, Elmer Trett and Larry McBride and all those guys, those that's who you wanted to be, and now it seems that Pro Street is like the goal, and I'm hoping with this NHRA opportunity, where fuel is back in vogue, so to speak. That
Right.
people want to join that. They're joining the Nitro Club.
Absolutely. No, that's great. I know a lot of people are looking forward to it. Probably none more than yourselves, but should be really cool to see what you guys do. Again, with that additional exposure and see what it does for your class, but also what your class does for NHRA. Right? It's kind of a double-sided thing.
I hope. Greg and I were talking about this last night, and Joe, we've talked about. We're since it's more of a business, type thing versus like, I think we were having a training session and Greg said, all right, this isn't throwing your bunch of stuff in the trailer and going to your local track, since we were trying to, expand our team and spread the knowledge, like I said, grow people. And I lost my thought, but the opportunity to grow the sport, is the biggest thing.
Yeah.
I think that we need, it'll give the opportunity, the exposure will hopefully get people, younger people, some more interest in it, because a lot of the people that do it now we're getting, shall we say, a little further along the way than, and we need some young blood and some new blood, and some new people involved, and hopefully this exposure will bring that interest and have people, get excited about being in Top Fuel again, as Dave said.
Yeah, definitely. And so speaking of getting excited about, motorcycle drag racing and specifically, the Top Fuel class, let's talk a little bit about, some of the specifics of that motorcycle, of the engine. I hinted at some of the speeds and the ETs that you guys reach out there on the track, but could you guys elaborate on, kind of what those fastest ETs are, what specifics go into some of the engines and the bikes?
I'll give you some numbers. The specifics, you'll have to talk to these two gentlemen. I believe our fastest, or our quickest run is a 5.71 seconds. The fastest pass ever is a 5.50. Our top speed is 257, and I believe the top speed ever is 268. And that still puts us, probably in second place speed wise, and probably fourth time wise. And what it takes to do that, I'm that, you hear it all the time. I'm the guy that just sits on the thing and holds it wide open and tries to get it to the other end. But how to make that happen, that's these two gentlemen here.
Yeah.
Well, they're very elaborate machines. I mean, there's a lot that goes into making a bike go 257 miles an hour safely. Yeah, that's the main thing. I mean, you want to make sure that Dave and the motorcycle come back in one piece. So the engines are 1500 cc's. The combination that we use about 1500 horsepower, and that changes up and down depending on what nitro percentage you run, what blower combination you run. That will go up or down. It has a 10-stage clutch, has MSD ignition. It's essentially a Top Fuel car without missing two wheels. Same basic components that you would see on a Top Fuel car. So as I say, there's 50 to 60 things you can adjust on any given run to make you go, hopefully improve your performance in the next round. And we're looking at all of those things all the time, whether it be weather, tune up, track conditions, everything, in between each round and in the evenings and in the morning, and we're watching it all the time.
Well, the biggest differences too between a Top Fuel bike and say a Pro Stock is our parts, just because of the horsepower we make, are meant to be extremely robust. Like it's a hard environment for our parts compared to, like, say, a Pro Stock motorcycle, very high revving, lighter parts, weight's more of an issue to them. Our stuff is robust. That's one of the biggest differences as well. So.
When we talk to those guys, you'll notice that 14,000 RPMs. These are kind of like diesels. If they see 9,000 RPMs, it's a lot, because they don't spin. Because like Joe said, everything is heavy. Because nitro is there's an old adage which everybody probably knows, that nitro is not your friend, and if the parts can't take it, you'll find out about it pretty quickly.
Yeah. And guys, speaking of parts, what types of materials are you guys using in stuff like the rotating assembly? Like, is that all billet components or is it other stuff?
The engine components, pretty much everything is aftermarket. The entire engine's aftermarket. I always say there might be a cam roller in there you can find that you could call stock, but that would be about it. Our engines are called Suzuki just only because they're based on Suzuki bore spacings, but beyond that, everything in it is aftermarket.
I mean, the blocks are billet, the cases are billet.
The cylinder heads are specially made. Everything is aftermarket, and the components are made to a higher strength and capability because they need to be because of the nitro, and because we're also running with the blower, we're running 50 plus pounds of boost out the back door. So they need to be robust, as Joe says, to just to survive that environment.
Yeah, absolutely. Now, you guys hinted at a couple differences between the top fuel class and what people might be familiar with in pro stock. Is there anything else that kind of makes those classes different than what you guys have already kind of outlined?
We certainly, because of the, it's all power related, our wheelbase is, quite a bit longer. They've upgraded from carburation to a fuel injection system. Most people, it's a fuel injected carburetor as a, half step. We have what is in the, your audience probably knows as power adders, a supercharger in our case, our turbocharger or a pro charger. For us, we use a supercharger like a nitro car, and they're again a pro stock. It's a normally aspirated motorcycle. They're very technical bikes. What they do is amazing. But we have the power adder, and so it gives us the ability, obviously, to add power. And with that, you have, just the acceleration. You have to have a longer, heavier bike, otherwise it would just spin the tire.
Right.
So for us, and they, ours is kind of pulley driven. The electronics are coming. If your audience is familiar with Pro Street bikes, they're tuned from a laptop. They're extremely electronic, where fuel bikes are somewhere in the middle. It's Joe will tell you, some of the controls that we used to have in Pro Mod are just now coming around in Top Fuel. Years later, I'm like, for me, it was like, so if you want to do that, you got to put on a different pulley, and I'm like, oh, okay, versus taking a ball on your laptop and, scooching it up a little bit,
Right.
So those, I think, are the big differences. It's just, size, and, we have power adders.
Okay. Very
The pro
good.
stock is not allowed to have, that's the stock part.
The
Yeah.
chassis difference, I think their wheelbases are maybe 80 inches, high 70 to 80 inches. Our wheelbase, yellow bike 99, new bike is 109 inches. So they're much longer, quite a bit heavier, because they are very, very reliant on weight. They do everything they possibly can think of to get rid of every little bit of weight that they can. We try, but we're not so dependent on weight as they are. They use I believe it's a 6-speed transmission that they run. I believe we're just a 2-speed B&J transmission. So ours is just have a low and a high, shift once and it's on its way. But they're very, very precise on their shift points. They have to hit their shift points in order to make good runs. So there's a lot of small differences in them, but generally the main one, normally aspirated versus power adders, and just size and weight of our bikes.
Right, like to go back to the RPM statement, like their power band is much smaller. Like they need to maintain that certain RPM. Like Greg was saying, that's why the shift point is like so specific. Where ours, just because of, like David said, with the power adders and stuff, yeah, it's nice to stay in a tighter RPM window, but we have a little more forgiveness, I guess.
Yeah, that's a good way to put it. To use just ballpark terms, pro stock is more of a finesse type thing, and nitro bikes are kind of bull riding.
Yeah. All right. Now, guys, you hinted at the weight of the bike a few times. How heavy is the Top Fuel motorcycle? And I know a lot of people are also curious, what do you guys do to stop that bike? Is there a chute, or is there another way you guys just slow down?
And there's two things. I'll let Greg or Joe comment on the weight. I think is it.
Well, the yellow bike is 900 plus rider. The new bike is 970 something, I think, plus rider.
That's right.
So, you know, we're always telling our rider that plus rider. So if the rider loses 10 pounds, then we just save 10 pounds, you know. But no, that's about the weight range. So we'll be in the range of 1100, you know, 1200 in that range, rider. And by the time you add nitro, because nitro is pretty heavy, you add 6 gallons of nitro. You're adding 60 pounds up in the front. So you're in that 1200 range, you know, 1150, 1200 range.
Yeah, stopping, and it's another advantage with the NHRA, like the rail cars and like the funny cars, we will be racing 1,000 foot to the 1,000 foot mark in this coming year, and that does help stop. If anybody is, you know, wondering, we cover a little more than a football field a second. So, you know, so if you take 1,000 feet and 320 feet, it's like 1 second, and but that gives us another second to stop. And we do use a parachute. NHRA requires an electronic thing, so if you sort of fall asleep at the wheel, or if you have brain fade, or if the car guys, when they whack the wall, sometimes they hit their head on the side. That's why they have the padding now. They literally get knocked out. And this, and if your foot happens to hit the floor, it's probably not good in an 11,000 horsepower car when you're out cold. They have a receiver and a transmitter that throws the chute, turns the fuel and the ignition system off 400 feet after that transmission. We would rather, of course, be ahead of that. But, if you, for some reason, don't do it, it'll do it for you. And that's how we get the things stopped. One of the things that you have to learn as a rider is the faster you go, the quicker you need to react to the brakes, because you're covering more ground than you used to be. And so you have Mr. McCarthy wrote one time, which I wish you had never said, that if you don't stop these bikes within 7 to 8 seconds of crossing the finish line, you're off the end.
Mm-hmm.
So
yeah.
Yes, but that extra 320 feet will help.
Yeah. All right. Very good. So, guys, we also kind of touched on a second ago, parts attrition and just what happens between rounds, but I want to dive deeper into that specifically. Do you guys just use one engine and replace the parts between rounds, or are there multiple engines there at the ready? If you need it, but talk about what you guys are doing between rounds, once the engine's kind of apart.
We have a very set, and again, this comes from repetition of having the same people doing the same job as much as possible, because that minimizes mistakes. So we have a very set schedule of things that happen when we come back from a round. We need to blow the bike out, which is basically blowing any leftover nitro in the cylinders. We blow that out. Let's take the spark plugs out, blow that nitro out of the system. And then we do what we have a test that we can do on the motor to see if the motor is still in runnable condition, called a leak down test. So we test all 4 cylinders quickly. And if they're all good, if they're 20% is a good number, 20 to 22% or under, then we basically say we have a good motor. Meanwhile, Joe or somebody will do a download of our computer that of that run. Go get the computer downloaded. If we determine the motor is okay, we'll check at the same time. We'll check our tire to make sure we haven't cut anything or put any chunks in it. And at that point, then if everything's okay to that point, then our oil guy will go in, drop the oil. We have 3 locations. We drop the oil out of the tank at the back, out of our dry sump tank, out of the engine. All of those 3 points, the oil's dropped out, oil's replaced. And then we get fans on the motor to cool it down. basically, and get the clutch cooled down.
And we do have 4 motors currently, and typically we've ran 6-8 passes on a motor before. That's typically not normal, but they do last. Like I said, we do carry 4. On a good weekend, we'll probably end up going through 2, one during qualifying, and then just to be safe going into eliminations, we tend to replace it. It's what do I want to say?
Safety.
Safety. It feels good to have a fresh motor in to go into eliminations.
Pull that in there for the
Right. It's a military term that we used to, hear during like maybe the Iraqi war, where 2 is 1, 1 is done. And we try to, have our parts list like that. So basically anything that we order 2 of. We have 4 complete engines. Pit speak is 1 on the rails, 1 on the floor. So if you go into Sunday, you better have, pretty much a fresh bullet, in the rails, and you better have 1 on the floor, because you're going to probably wing 1 if you go long. Long means, when you head to the final, you're going to probably lean on it pretty hard because the competition gets, stronger throughout the day. And that means you got to pick your game up, which, increases your chances of damage.
Yeah.
So, at some point, you're like, yep, that one's hurt. We do a leak down, and like Greg says, it's like 20, 20, 80, 20. And you're like, yeah, that's out of here. And at that point, what they didn't touch on is that was Greg's comment was if everything was fine. And if it's not fine, at that leak down stage, you find that, whatever is happening, you don't have enough compression in that one particular hole. We change motors. To answer your question, we don't take stuff apart.
Our typical failure tends to come from, like, we have very, very strong exhaust valves, but the seats inside the cylinder head can't keep up. And so typically what happens is we have a valve that starts to float. So now the compression in the engine is just going out through the exhaust valve, because the exhaust valves either donutted on the stem or become bent just from cycling so fast. And then you can hear it just coming out the exhaust pipes. And I can almost be in the trailer sometimes and just tell, like, yeah, no, this one's coming out, because you can just hear it pouring out through the exhaust. And it's a lot of the times it's pretty obvious that it's coming out. So
yeah. And so, Joe, you just mentioned the exhaust valves. What are some of those other components that just kind of get beat up more than others when you guys are doing a run?
Like I said, the exhaust valves are one of the major ones. Ringlands, just due to the nature of the supercharger of the nitromethane itself, we try to squish it as much as we can. I often say we don't burn nitro, we kind of control an explosion. So you'll see ringland damage, crushed rings or pistons where the lands have become rounded over. So now the seal is basically gone between the piston ring and the cylinder wall. Those are basically big. Our intake valves are fairly robust. Again, we've had, I can't remember any crank or cam related failures. So it's typically valves or piston rings.
Yeah, those are the things. Our bottom ends and that are pretty bulletproof for the most part. You never say never.
Correct.
But touch wood. But I mean, for the most part, it's going to be valve problems we're going to have. I mean, we've managed to run this combination for a number of years, so we pretty much know when we're pushing the limit of how far we can go with nitro percentage, blower pulleys, and if you get aggressive and you're you want to go for it, well, then you're taking more of a chance of hurting something, and that's pretty standard throughout racing. The harder you push, the bigger chance you're going to have of hurting something. So
right. Absolutely.
Yeah, the lower ends, if I heard it right, those cranks and cases are spin balanced at 20,000 RPMs, and we don't even do half of that. So I think that's part of the reliability issue is, we're really not even coming close to what they're capable of.
Yeah. Oh, very good. All right. Before I jump to my next question, I just want to remind the audience, if you guys have questions, make sure you guys are putting that in the ask a question box. I do see that there's a few in there, so We will get to those here in a moment. But guys, as we're talking about the action that's happening between rounds, we talked about how well PennGrade1 oil has worked for you guys and the long-term relationship that you guys have had with the oil. So how does the oil help, in your quest to keep the engine running well? And what's the environment like for the oil in something like the Top Fuel motorcycle?
I think Dave touched on it a little bit. I mean, with the amount of boost and the amount of fuel that's going through that motor, the oil is subjected to some pretty tough conditions mixed with the nitro and pushed through the system. And so that's why we have to take it out each round, because it comes out a green, soupy oil nitro mix. And for it to survive under those conditions is pretty impressive.
One of the best things about the PennGrade1 oil is the zinc content. That's one of the things we attribute to our extreme lack of failure as far as our bearing surfaces go. It's this stuff. It's about the thickness of maple syrup. It's pretty amazing, and like I said, the protection that it provides is unmatched in my mind. So.
Yeah, it's hard to get off your hands if you almost have trouble washing it off your hands. And so if it sticks to the motor like it sticks to most things, then that's why we're getting the durability that we are.
Yeah, no, you guys are certainly not the first ones to make that claim. So absolutely, it has that clingability for sure.
It does.
So I also wanted to know, the viscosity and weight of PennGrade1 that you guys run, how does that compare to maybe some of the other classes? What type of oil they might run, or just a regular motorcycle on the street? How does that differ?
Well, I believe rail in front of cars run all the way up to a 70 weight. We're a straight 50. I don't ride motorcycles, so what is like a typical?
Yeah, I would say we run straight because there's not much of a temperature range. Where if you ran a 2050 or 2030 or 2040 or a 1540, depending on if it's synthetic or not. A lot of that has to do with temperature range of starting. That I understand it. The environment that we're in, we don't need we just use a range that we operate in, and so we're allowed to run a straight 50. Now Nick, who's a 40-year oil god, he may be better at a question if he's doing audio. I'm not sure. I know he had a video connection problem. But the difference is your everyday stuff has a range, and we don't, because we don't have much of a range. These bikes operate pretty much consistently. We're not stuck in traffic. We're not going down the highway. We're not doing this. We're not doing that. Of all the conditions you could have, we don't have those conditions.
We don't run them in the winter.
We don't run in winter too much,
Yeah. No, very good. Excellent. All right. So I believe Greg had made a comment related to data and the things that you guys are looking at between the rounds. But Joe, I know that's something that you kind of specialize in. So, I wanted to ask you a question specifically as to,
sure.
Once the bike's back together, once the engine's good to go for another round, what's some of that extra data that you're looking at to really, improve upon the performance?
Right. So when it comes back, like I said, the various team members start the leak down, the blowout procedure, changing the oil. One of the first things I do is I pull a data chip out of our data logger and download that into my computer. And I think at some point in time, I think we have another slide that we could show. We monitor, that's the one right there. We monitor 30-something plus channels, everything from engine RPM to boost pressure, clutch slip percentage, the EGTs for all the holes, acceleratory Gs, fuel flow. And then the other bigger one is also the weather. So we basically see what we did. We know the tune-up that we put in for that run. We see how the engine performed, the temperatures that we reached, how the clutch reacted to the different tuning changes. And then we try to forecast by the weather what the next round's going to be. So if it's getting hotter, we might want to slow down or speed up our blower some. If the air's looks like the DA is dropping off, if the temperature is dropping, then we need to slow it down just to try to keep our power level consistent. One of the biggest things is like kind of eliminating variables. I tend to run the same nitro percentage at all times and basically use my blower, the different pulley ratios, blower ratios, to keep our power level the same. And once we have that kind of figured out, then we start working more onto our clutch. And that has more to do with how the track is, you know, the temperature of the track, how aggressive we can be in the 60-foot. We have a meter that tells us basically the grip. You know, so like I said, a lot of it is just you're almost a fortune teller. You're trying to figure out what's the next one's going to be, and make your small manipulations to the tune-up to be prepared for that.
And we try to do it from a mathematical standpoint. You know, the days of, you know, walking up there and, you know, moving your foot around a little bit, you know, going, yeah, I think it's pretty sticky. You know, now we can, you know, we have a meter, you know, that, you know, a number comes from it. So we can say it's a 300, it's a 350, it's a 400. You know, not like, you know, oh geez, you know, it feels pretty good. You know, we try not to do that stuff anymore. So if we can measure it, we try to measure it and use the numeric, you know, calculation into the thing. And to Joe's point, you know, that's the crystal ball, you know, saying, well, hey, the weather's changing X, you know, every 20 minutes, and we're going out in 60. So we'll try to do that. But then if a cold front comes through, or, you know, somebody oils the track,
you may
you know, all of a sudden you miss a tune-up because, you know, it went long or went short, or geez, we didn't, you know, that weather station for some stupid reason, you know, you didn't see the cold front coming through.
And Greg and I also, we have folders of old runs that we've made. So that's another that you look back at, like, okay, we have 80 degrees, we have this percent humidity, we have that much DA, we have that many grains of water. We know what the track's like. We go back into our notes, be like, well, we made a really good run in these similar conditions, you know, 2 years ago. And that helps to almost predict, or, you know, like I said, knowledge is key, and you know, note taking and having data is extremely important. So.
And what we're trying to do, a lot of times we try to find a baseline early in the weekend. And once we find a baseline that we're happy with, a lot of the changes that we're making through the weekend. And now that, having said that, the weather can change from Friday to Saturday and be a completely different day and completely change your tune-up. But what we try to do is just make small changes. So we're looking at various little pieces of the graphs and saying, well, we could fix this piece right here, as opposed to making an overall change and changing the whole graph. We're just looking at parts and pieces of it to try and pick up a bit here and there. Yeah. And that's a lot of what we're doing when we're looking at the graphs.
Yeah. Excellent. Now that's super fascinating stuff. And, you know, I think the casual fan, you know, probably has no idea that you guys are looking at that much data and changing, you know, those different aspects between rounds. So it's super cool to know that level of data and that level of input is going into it. And speaking of
in any professional category, I think you'd find that, you know, that's a large percentage of time spent, you know, changing engines. That's kind of like in, out, nuts, bolts. But, you know, massaging a tune-up, you know, there is a lot of data.
Like you see, like you have my weather station up there, the screenshot I took of you, and the viewers can see in the lower right-hand corner, that's a horsepower ratio, and you can see the massive dip it takes. And I know just from looking at it, that is because as we've gone, that's basically morning to night or afternoon into night, and you can see that the horsepower increases quite dramatically because the DA's gone up, and also the humidity has dropped way off. So the air's become a lot drier. The supercharger is going to make a lot more power because of it, and therefore, you know, we've had to modify our tune-up, actually come back off of blower, you know, go down a smaller pulley or larger pulley just to keep our power level the same. So,
yeah, awesome. Well, guys, speaking of, modifying and making advancements in the performance you guys are looking for, I'm sure fans of the team and fans of motorcycle drag racing have heard that you guys have a new motorcycle out there and have been testing it. So I wanted to talk a little bit about, what some of those differences are between, the bike you guys were running and now this new bike that's going to be coming out.
I guess it would be, I mean, go ahead, David, if you want.
No, I think Greg started down the road of wheelbase difference and et cetera. So please continue.
Well, I think the big difference is in the chassis technology, for one thing. I mean, the yellow bike is back in the vintage of 05. Its first run was in 08. And the chassis technology back then was weight transfer and trying to get the front end up in the air and transfer the weight onto the back tire. That was kind of the thinking back then. As time moved on, and this newer chassis, it's about keeping both wheels on the ground and forward motion as opposed to bringing the tire up. It's about going forward, and with the tires basically on the ground. And so it's just a different thinking in the chassis design. For one, that's one of the bigger things.
Yeah, because like force power is measured in vectors, right? So if you have your front tire in the air and your bike's still accelerating forward, you're using force in two different vectors, right? The more you can keep all your force in a forward direction, I mean, the better off you're going to be.
Yeah.
The other big thing about this is just newer technology when it comes to the fuel system, when it comes to some of the major components. A lot of the components are the same, but it's just a newer, up-to-date fuel system. Some of the clutch control is updated, and so just newer technology. I mean, the yellow bike is still a great bike and still has some potential, but that new bike is that's the future right now.
Yeah.
The thing that I would add to that is, if I might, is we've played around and have 2 to 3 versions of exhaust pipes to go along with the chassis. Mm-hmm. So as you've probably seen with cars, instead of them coming up as much, they're starting to get rocked back more, so that you can use a little more thrust. So we use bars generally that stand up a little bit more on shorter tracks because you don't go as fast. And on big long tracks, we use more of a laydown pipe to use that thrust as part of an accelerator.
Yeah.
So pipe design, along with chassis, along with track length, is a consideration when you're chassis tuning, and chassis tuning is very important. I finally won the battle because these guys are fuel tuners and this tuner, and I'm like, you can make all the power you want, but if I can't get it to the other end, we got a problem. It's not a knock on these guys. I mean, the thing is, it's going so darn fast that it's unmanageable, which is nice, but it's unmanageable. So, so they're really doing their job, and it's like, don't forget the chassis, because this bike is blistering fast, but it's also got to go semi-straight, and right. So part of going quick is going straight. In drag racing, we always kid around by somebody took the long way down, which means they're all over the place. So 1,320 feet turned into 1,350.
Yeah.
Where are you going? You just made the track, 2/10 longer,
right.
Kind of thing.
Right. Very good. All right, guys. Well, I've got one more question for you, and then I'll jump into some of the audience questions that we've got. So again, for anyone still on the presentation, make sure you guys are asking those questions if you've got them. And Dave, Greg, Joe, this is just kind of a forward-thinking question. Again, with this news that you guys are going to be a class in the NHRA, it's certainly a big deal. But where do you see the future of the top fuel class going from here? And beyond that, what do you see for the future of the team and future of the relationship with PennGrade1?
Well, I believe the NHRA, as much as you hate to say it, was a bit of a Y in the road for us. I mean, we it's a great thing for Top Fuel Motorcycle and hopefully for NHRA. So I believe that if we can do a good job and keep the fans excited, that I believe that the class will grow, the interest will grow, the interest from a standpoint of people wanting to get back into Top Fuel will grow. And so it's very exciting, and it's all very good.
As far as running two bikes now, it's been nice to kind of graduate some of our team members up into more or different roles, newer roles for them, and I mean that keeps it exciting too. I mean, I guess you can probably only change oil so many times, and you want to do something else. So it's nice that we've been able to grow with two bikes, and like I said, grow people, as team members as well.
So Joe's exactly right. We've been able to elevate people up through the ranks. We try to feed from the bottom. Sort of a seniority type, and ability combination, like any business would. As far as our relationship to what's next, I would say that I think that's a side effect of where we are with NHRA, and hopefully it provides, like Greg said, the opportunity and the interest level, so that there are people that are like, hey, that's something I think I could do. And we have, as a team, and I know as a class, because I've talked to some of the other guys, is that and I think they're getting to the point where they realize they have to start sharing and quit hoarding information and ability, and start teaching. It's the old, hey, it took so long to train that other person. I could have done it in half the time myself mentality. And people just got to stop doing that, because in the end, I think that's a loser approach. It's an easy approach. It's like, oh, I could have done it in half the time and twice as good. Well, you're never going to have a replacement that way. As far as PennGrade1 goes, I would say it's all the same. We're a good testimony, or at least I hope we are, to PennGrade1's success. If the class grows and we're influential, which I think we are, we will steer people to PennGrade1.
For sure. Yeah, hopefully for many years to come. That's for sure.
Yeah.
And we, I anyway, am of if it ain't, I'm a more or less if it's not broken, don't fix it guy. And if we're having good luck with PennGrade1, and we are, we're going to stick with it.
Because oil is something that you don't want to mess with. I mean, you can have somebody come up and say, hey, we'll give you our oil. And my answer would be, why would I possibly want to change when I have something that works? Because the results of that oil change could be catastrophic in terms of a lost engine or something worse. So if it works the way PennGrade has for so long, I can't see any reason why we wouldn't.
Yeah, the risk is not worth the reward.
No, absolutely not.
The engines, which do not include the transmission, nor do they include the clutch in these motors. It's strictly a crank, pistons, block head.
Yeah.
Are about $30,000 each. And if you were to have a failure because somebody's like, oh, my oil is just as good as PennGrade1, and you go, I mean, if I stick my hand out and go, well, you were wrong, and that's $30,000. That's probably not going to happen.
Disappear pretty quick.
Yeah, they won't be there very long.
I mean, like you said, if it ain't broke, don't fix it. I mean, it's been the oil. The product itself is amazing, and the relationship that we've had with PennGrade1, with Nick, and everybody, like it's really been one less thing to worry about. Honestly, like it's
good peace of mind.
Yeah, it's a great peace of mind for sure.
Yeah,
absolutely.
Excellent. All right, guys. Well, with that, that wraps up the questions I had for you. So, Dave, like you said, rather than keeping all that knowledge to yourselves, we appreciate you guys sharing some of that with us. And now we can jump into a couple of the audience questions that we have. But before we do that, I do want to ask everyone on the webinar today to please complete our survey. Because audience members, we do need your feedback. It helps us, as I mentioned. And as a special incentive to complete the survey, we're offering a $10 Amazon gift card to 25 randomly selected people who complete the survey. So that should be appearing on the screen here shortly. If you don't see it, you can launch it by going to the black toolbar on the left of your screen and clicking the survey icon. All right, and as you guys are answering some of that, I will get into some of these questions here. And starting at the bottom here, we got a question about wanting to get a further explanation on a hurt tire. How long does a tire change take on the bike?
So a hurt tire, I mean, like we've gone through basically use a tire one a pass, and we normally, we cycle them out after about 8. That's just, again, we rarely let something fail before we change it. So if we get 8 out of a tire, I mean, that's pretty good. In order to take a tire and change, probably,
we have 2 rims and 2 tires, so we'll usually have one in the trailer mounted and balanced. To actually change a tire on the rim, you're maybe looking at half an hour to change the tire and another 15 or 20 minutes to balance.
Right.
We set up, we have a balancer. We have a balancer that we set up, and we spin the tire and put weights on it and balance the tire to balance the rim and tire, because the balance weights will change from tire to tire.
Because Dave likes his fillings. Yeah, but yeah, I mean the damage, the indicators are visual. The worst case, like Joe mentioned, was at one point, depending on how the track is prepped and depending on where you shut off the fuel, will actually rip. We call it chunking the tire, where it rips chunks out. So there's a visual failure. The other, to Joe's point, like the number of runs, you can, you just look at your time slips.
Yeah.
If your 60 foot just keeps going, getting longer and longer and longer, it's like, that tire's got to go.
Yeah.
It's lost. It's sticky. Whatever it is, it's not. It's going the wrong way. Out. Yeah. That's how it works.
One other interesting thing is that we don't like to start eliminations on a brand new tire. So just on a last qualifier, we might put a new tire on just to get a run on that in a qualifying, so that we're not going into eliminations with a brand new tire.
It takes a couple of heat cycles to activate the adhesion of the adhesion of the tire to the track. Like, I mean, a brand new tire tends to have a gloss on it. It's the release that was inside of the mold when they made it, and it takes a few cycles to really get that to burn off or dissipate out of the tire.
Yeah. So there's a bit of strategy involved in when we'll change them, and when sometimes we just change them because there's a chunk out of it and we just need to change it for safety reasons. Other times there's a bit of strategy involved.
Yeah. All right. No, that's very cool. All right. We got a question about the challenges that you guys encounter in managing engine temperature during a race, and what type of cooling solutions you've implemented.
There is absolutely no cooling. The cooling is going 257 miles an hour. That's about all. There is no cooling system on the bike as far as a radiator or anything else. The oil itself does help keep cylinders temperatures down. But like I said, there really is no, I mean, I guess like we can run less nitro percentage. The higher the nitro percentage, the higher you're going to get temperatures. The other biggest thing is timing curves. The more degrees of timing you run, that definitely elevates your engine temperatures. So.
Challenges are a lot of the challenges are weather. I mean, you can go through a massive weather change over a weekend from very hot, and then it can drop 20 degrees the next day. You can actually see quite a change. If we go up for a round and there's an oil down, as Dave mentioned, we might sit there 2 hours. Well, that change in weather over that 2 hours can change your tune-up, and also change the effect of the temperatures of the engine. And so there are some things we can do at the line, but we're always watching the weather. The weather is probably the biggest single thing that we have to watch when it comes to the engine.
We've sat in the lanes and changed pulleys just waiting on the track to get clean. We've changed it about 3 or 4 times before a run, just because we had the setup. An incident occurred, and as the weather just dropped like a stone, we had to keep coming back on the blower. So yeah, like I said, there's a fair amount that can happen.
We do have several programs that we can run. So we have in our command module, we'll have a safe program, we'll have an aggressive program. So if we're watching and the weather's getting significantly better, we might have a program in there that has a degree or two less of timing. We can go in and put that program in about 15 seconds and calm the engine down a little bit. So that's something that we're always watching when we're up at the line. Getting stressed out.
Yeah, we have an ideal, it accepts 3 tune-ups, and you sort of, it's mama bear, papa bear, and this one's just right kind of stuff. So, you leave the one that you picked in, and if the weather gets better, you use the lesser one, and if the weather gets worse, you go big.
Or do you roll the dice and go for gusto?
So, we have that. I believe, Joe, don't you have something on your phone talks to the weather station?
Mm-hmm.
So, Joe, we have technology is that such that Joe can sit there in the staging lanes if there is an oil down situation or whatever. His cell phone can talk to the weather station, and he's like, "Oh boy." And I'm like, and the next thing, he's running, he's gone, he's getting tools and pulleys, and he comes back, and
I can set my phone so that if certain parameters change a certain amount, then I'm notified of it. So say the density L2 drops 50 points, well, then my phone lets me know, and that's when David sees me running. So.
Excellent. All right, well, guys, I know we're just a bit over an hour here on this webinar. So again, we appreciate everyone sticking around. This has been a great conversation. We do have a few more questions to get to. So if you can stick around longer, great. If you have to drop off, don't forget that this webinar is being recorded and on demand. So there's plenty of opportunity to watch it back at your convenience. Joe, you'd mentioned the nitro percentage a couple of times, and we do have a question or two here about that. We got a question just asking what the normal, fuel percentage, the nitro percentage is that you run. And then we got another question asking, how you optimize that fuel air mixture, ratio to achieve, the maximum power you can.
Well, I mean, we'll kind of answer the second one first, because I don't know if I'm going to answer the first one. But we actually, these bikes, they don't have air fuel mixtures. Like a lot of street bikes or performance cars or vehicles will tell you where you are, and you typically want to be around stoichiometric for your air fuel ratios. We don't have one on this. And I think a lot of that really just goes back to the notes and the knowledge of the air parameters, like what I'm seeing on the weather station, to knowing how much blower, because I do, if I don't have to, I don't change my nitro percent. And I guess it's 93. That's my magic number. I tend to run 93% constantly because it just does eliminate one variable, and I know how it's going to react. And then from there, it's really just a lot of data, knowing track condition, weather conditions, and then that sets the blower. And I know I'm going to be in a range that I'm comfortable with.
Yeah. Yeah. What we found is, below 93, it causes issues because, with nitro, you can actually hurt a motor just as much going too slow as you do too fast, believe it or not. And so that's kind of the sweet spot. And what we've also found is, at least the parts that we run, which are, pretty much as strong as you can get for a motorcycle, anything over that, it's a one-way trip.
We could run a Husky 93, but it doesn't like 94. I'll tell you that much.
And it doesn't seem to be any performance advantage. Going past 93, we don't see, more is not better at that point. So 93 is about where we end up at, and that's where we pretty much stay unless the air is so good that we might have to take it down a bit. But for the most part, that's where we are.
Yeah. All right. Excellent. We've got another question here from a guy interested in just understanding the EGTs that you guys are experiencing on a good run.
So that a lot has to do with piston piston makeup, the metallurgy inside there. On a good run, I'd like to see it about between 13 to maybe 1420. Anything over 1420, I tend to see piston damage. And anything under 13, we're not optimizing the load, the charge of the air in the nitro itself.
Just to be clear, that's 1,400.
Yeah, I'm sorry. Yeah, 1,000. Yeah, sorry. I just call them 13ths. But yeah, like so, like 1,350 to 1,380 is probably optimal. I can sneak up to 1,420, but much past that and work.
If you do take your motors apart, you would use a ball hone and acid. Put it that way, over 1,400 degrees.
Yeah. Very good. All right, guys, I'll hit you with one last question here. Again, going back to more of the oil side of things. We got a question about where you guys set your bearing clearances for the 50 weight oil. If that's something you're...
That's more of an engine building topic that I don't know if, yeah.
Yeah, our motor program is we get our motors from the McBrides, and some of those questions are not ours to answer. So I appreciate the question for sure, but
yeah,
it's not something that generally we talk about too much. Hopefully that's okay.
Yeah, no, fair enough.
That's builder. That's a builder question, and we're not, engine builders.
Not a problem. And again, some of that stuff is information that people might not want to share a ton of info on, especially at the competitive level that you guys are at. So,
I can plead ignorance. To me, the engine comes back and it's assembled, and I'm told it's good. It's good. So,
yeah.
I really don't know.
All right, excellent. Well, guys, again, really appreciate the time. I want to, again, thank everyone for tuning in and watching, this webinar here, again, sponsored by PennGrade1. I want to thank them and thank the Vantine team. Thank you guys very much. And again, just a reminder to the audience that a recording of this webinar will be available on both Engine Builder and Motorcycle and Power Sports News websites. So feel free to log in to view it again, or encourage others to view it. And tomorrow you guys will receive an email that contains a link to the recording. So Dave, Greg, Joe, thank you guys very much. I appreciate the time.
Thank you. Thank PennGrade1. Thank you very much. Appreciate it.
Thanks, PennGrade, and hopefully we'll see you at NHRA.
Right. Come on out.
Yeah.
Have some fun.
Absolutely. Yeah. Get to the track this summer. Well, thanks everyone for watching. That concludes today's webinar. Thank you.